Let's jump right into this explainer. Today we're unpacking one of the absolute most fascinating origin stories in modern tech history. We're going to look at how a bitter 1957 corporate rebellion directly birthed the modern microchip and really the world as we know it today. Okay, let's dive into this. How did one terrible boss accidentally create Silicon Valley? It's kind of a wild historical paradox, right? The foundational tech was born way over on the East Coast at Bell Labs, but the actual revolution? That happened in California. So let's look at why. The story starts in a converted Quonset hut at 391 San Antonio Road in Mountain View, California. The year is 1956. William Shockley, who had literally just won the Nobel Prize in Physics for inventing the transistor, decides to start his own company. He crisscrosses the US and manages to assemble an absolute dream team of young PhD graduates. We're talking brilliant physicists, chemists, and engineers, mostly in their late 20s or early 30s, and they are incredibly eager to build the future. But, well, things quickly went south. See, the initial goal of the new firm was incredibly practical. Figure out automatic ways to mass-produce diffuse-based transistors. But Shockley shifted gears. He completely lost interest in that original, viable goal and became obsessed with the Shockley diode. Now, this was a complex four-layer component that looked brilliant on paper, but it was an absolute nightmare to actually manufacture. It required flawless precision on both sides of the silicon, making it super unpredictable. His staff, which included visionaries like Robert Noyce and Gordon Moore, felt this was just way too difficult to pivot for a young startup. Combine that quirky R&D obsession with Shockley's heavy-handed, authoritarian, and frankly deeply unpopular management style, and man, the tension became palpable.
The whole thing finally boiled over during a meeting in mid-May of 1957. Arnold Beckman, the company's financial backer, had come up to discuss the division's melting problems. Shockley, taking major offense at his partner's proposals, just stands up, stomps out of the room, and shouts something to the effect of, "If you don't like what we're doing here, I can take this group and get support anyplace else." But here's the deeply ironic twist. Nobody left the room except Shockley. That explosive, embarrassing outburst accidentally pushed his brightest minds right out the door.
Let's move along and see how this builds, because the wheels of rebellion were actually already in motion. Back in March, Eugene Kleiner had supposedly asked for permission to visit an exhibition in LA. Instead, he secretly flew to New York to hunt for investors for a brand new company. After that May outburst, the rift was simply too huge to overcome. Gordon Moore stepped up to lead the dissidents. And finally, as Shockley briefly jotted down in one of his own notebooks, on Wednesday, September 18th, the group officially resigned. Shockley literally described their leaving as a betrayal, and they quickly went down in industry lore as the Traitorous Eight. That's Julius Blank, Victor Grinich, Gene Hoerni, Eugene Kleiner, Jay Last, Gordon Moore, Robert Noyce, and Sheldon Roberts. This wasn't just a handful of employees quitting, you know? This was the entire core intellectual engine of the company walking out the door. Led by the brilliance of guys like Robert Noyce and Gordon Moore, they were absolutely determined to build transistors their own way. And in doing so, they would effectively seed the entirety of Silicon Valley. Now, finding investors on the West Coast was incredibly tough back then, mostly because the electronics industry was heavily concentrated back east. But they managed to connect with Hayden Stone and Company. In this wonderfully vivid piece of history, an investment banker named Alfred Coyle met with the men. Coyle pulls out 10 newly minted $1 bills, lays them carefully on a table, and says, "Each of us should sign every bill." Those dollar bills, completely covered in signatures, served as their initial contracts with one another. And that quirky agreement rapidly led to a massive breakthrough in funding, a $1.38 million loan provided by Sherman Fairchild to officially launch Fairchild Semiconductor. Setting up shop just a little over a mile away on Charleston Street in Palo Alto, these 8 rebels suddenly had the serious capital needed to pursue the silicon technology that Shockley had abandoned. Now, what's really interesting is a specific piece of correspondence from December 1956, back when the group was still trapped at Shockley Labs. It's a letter from Western Electric containing a preprint of a paper all about oxide masking, and attached right to it was a staff routing list featuring the initials of the Traitorous Eight. That exact document gave the team a crucial early glimpse at how to use a silicon dioxide layer to pacify the silicon surface and etch intricate patterns. They took this foundational, game-changing knowledge with them to Fairchild, and it became the core enabling tech for everything that followed. Which brilliantly brings us to the immediate technical challenge Fairchild faced. Initially, they were manufacturing these double-diffused MESA transistors. The problem, MESA transistors had exposed junctions, which caused massive reliability issues. Tiny specks of dirt or contaminants could easily ruin them. The team desperately needed a way to protect these highly sensitive components. The big breakthrough was shifting away from that exposed MESA structure over to a planar structure, where those sensitive junctions are securely protected beneath a flat oxide layer. This brings us to a monumental innovation originated entirely at Fairchild, the planar process. Conceived by physicist Gene Hoerni in December 1957 and proven in March 1959 with a lot of help from J. Last, this technique used the oxide layer on the silicon surface to protect the sensitive PN junctions beneath it. Now, it sounds simple, but leaving the oxide in place rather than stripping it away, that was revolutionary. It completely solved the reliability issues and, honestly, ever since 1961, it has served as the fundamental basis of all microchip fabrication.
But there was still a massive roadblock to shrinking electronic systems, especially for the military. Even with Hoerni's pristine planar transistors, you still had to manufacture these tiny components separately, physically cut them apart, and then wire them back together by hand on a printed circuit board. This so-called tyranny of numbers meant that, as circuits got more and more complex, those hand-wired connections became impossibly unreliable and wildly expensive.
Enter Robert Noyce. He was actually the only one of the 8 who arrived with extensive prior semiconductor experience. Noyce realized it made absolutely zero sense to separate transistors that were already fabricated right next to each other on a wafer, only to tediously wire them together later. He envisioned what's known as the monolithic concept. His solution had 3 brilliant steps. First, use Hoerni's planar oxide as a built-in insulator. Second, insert extra back-to-back PN junctions into the silicon to electrically isolate the different components. And third, deposit a layer of aluminum over the entire surface, using a light-based etching process called photolithography to remove what wasn't needed. That leaves perfectly patterned metal interconnections. So the absolutely crucial point here is that by combining Hoerni's planar process with his own brilliant ideas for electrical isolation and adherent metal interconnects, Noyce had solved the puzzle. He filed a patent for a semiconductor device and lead structure in July 1959. It was exactly this, Noyce's specification of planar technology combined with flat aluminum interconnects that officially created the practical, mass-producible integrated circuit that we all use today.
The ripple effect of this invention, and of Fairchild Semiconductor itself, is almost impossible to overstate. From 1960 to 1965, Fairchild was the undisputed king of the semiconductor market. But eventually, internal management struggles and a loss of team spirit led the original 8 and their top engineers to splinter off once again. These spin-off companies came to be affectionately known as the Fair Children. Moore and Noyce, they went on to found Intel. Others founded or heavily reshaped giants like AMD, National Semiconductor, and Almelco. Literally dozens of massive tech corporations can trace their direct lineage back to that single group of 8.
But here's the thing. They didn't just invent a physical chip. They quite literally invented the culture of Silicon Valley. See, the traditional East Coast electronics firms and older California companies, they didn't trust Wall Street, and they maintained these rigid, lifetime employment hierarchies. The Fairchild alumni built something entirely new. They created a business strategy designed around venture-backed growth. They established a culture of extreme job mobility, remaining faithful to your colleagues and your technology rather than a single corporate employer. And, driven heavily by Noyce's influence, they openly rejected traditional corporate hierarchies in favor of open collaboration and flat organizational structures.
Which leaves us with this final thought. A single outburst in a Mountain View Quonset hut pushed 8 young scientists to break out on their own. They took early research, pioneered the planar process, invented the practical integrated circuit, and built a massive web of companies that powers every computer, smartphone, and digital system on Earth today. It forces us to ask, would the digital age as we know it even exist today without that ultimate act of corporate betrayal? It's a truly fascinating piece of history to chew on. Thank you so much for joining me for this explainer, and keep exploring.